Hello, welcome to the stream. We will move ahead to the next chapter, which is chapter 5, using struct to structure related data. Struct are, Structs are very useful if you want to, combine some related data to make some sense and to create our own data types. So, struct are similar to tuple. Like, inside of tuple, we can group similar data together. But unlike tuple, it has a name. Like every value has a name so that it will make much more sense. Like here, if we want to declare a struct, we use struct keyword and then declare it like this. Here comes the name of the structure. We are declaring a structure called user, and these are its field. What an user can have is a username, an email, a sign-in count, and active for the sake of argument here. And username will be of type string, email will be string, and these are just type. Active will be a boolean. And instead of making a tuple of two strings, one boolean and one u64, which will make no sense, we can use structure like this. Using this syntax. And when we want to create an instance of it, we have to specify the values for them, like we did here. No, let me zoom in. Yeah. So if we want to say let user1 be our instance of this structure user, and what it will have, we declare the values like key value pairs. We have our email, it will be a string. We saw this syntax to declare the string, not the string literal. We want a string, so we will have this email, have some username 123. We will set our active to true and sign in count as 1, and that is how we are going to create an instance of user. And if we want to access some particular field, and suppose we want to change our mail, so we can use this dot notation like user1, and after dot we can specify the field we want. Like if we want username, we will specify username like that. And notice here, because we are changing the value, we want to declare the struct as mutable variable. We can't just make the email field mutable and the rest all immutable. It won't work like that. We have to make the whole structure mutable by saying by using the mute keyword while creating an instance of it. And as all other expressions, this can also be implicitly returned. Like here, if we add some function, we don't have semicolon at end, which means this is an expression, and it can return a user. You can also see in function signature, it is returning something of type user. And that is why we said we can declare our own data types. So we can just return the user and it will build user for us. If we say the full function here, for building a user, we are passing two arguments. One is email and another is username. And we are just calling that function, and inside that function, we will return a struct called user. It will get assigned to this user1. And notice that we are declaring our parameters name as email and username, and struct has field of same name, the email and username. Now we have to repeat this: email equal to email, username will be username. And if our struct was too big, it will be like a lot of not so good thing. Instead, we can just, if the name of the variable or parameter here we are using is the same as struct field, we can just specify it directly. This syntax will work too. Instead of using this key value pair, we just say email, and this will work just as the above example here. This both will work similar way because the names were same. Rest compiler will do that for us. And suppose we had one user1, and we want to create user 2, but we want some values from user 1 also. One way to do is that we can, while creating a user 2, we will specify the values of user 1. Like user 1 dot active will be the active for user 2, sign in count will be user 1 dot sign in count. But as we saw, if our struct was bigger, it will be a lot of work to do. Instead, we can use this dot dot syntax. So we are explicitly saying email to be this and username to be this, and remaining all values will be same as user 1. If we didn't specify this two, it will all be same to user 1 only. So this dot dot syntax specifies that the remaining fields not explicitly set should have the same value as the field in that given instance. So the sign in count and active will be same of as user 1. And there is also another type which is called as tuple struct. Like, if you want to have a tuple but also make some sense out of it by giving it a name. Like if you had tuple like this, everything of type I32 and this also, but they are of different types. One is color and one is for point. Even though the black color and origin, the point for the origin and this values for black color look same, like this will be same, but this, if we use just the tuple, they will be same. But now this will be of type color and this will be of type point. If we add some function that takes color, it won't accept point even though they look similar or the values inside them are same. This makes the code a little bit more understandable and easy to use. And another type is the unit like structure, which acts like this. We saw that if function returns nothing, it is actually returning this. So it is called as unit type. And we will see when we want to use unit type later in chapter 10, because unlike unit like structs can be useful in situation in which you need to implement a thread on some type but don't have any data that you want to store in type itself. We will see about threads and all that in chapter 10, so we don't have to worry much about it now. And here comes the ownership of the structural data. We used string type rather than this string slice type because we wanted this ownership, right? Because we want to have our struct, the strings defined inside the struct as long as the struct is available. If you use the string literal, we need to use the lifetime. We need to specify the lifetime for it, right? We need some way to say that. So if it doesn't have any lifetime, we don't really know until when it will be a valid thing. We want our string to be valid thing as long as our struct is also valid. That's why for now we used string instead of string literal, but we will see about them how to fix that issue in chapter 10 only, like how to specify the lifetime. Here Rust compiler gives us help. We can actually do it like this. But yeah, we will see about it in detail in chapter 10. And here is like example for when you will like to use the structs. Suppose you want to create a program that has a calculate the area of rectangle, that has a rectangle, and we need to calculate its area. So we will go from step by step improving our program. First we will have single variables and we will eventually switch to structs and methods. So our simple program will be like this. Weight is 30, height 1 is 50, and we are printing the area by calling this area function. And what area function is returning? This is just multiplying weight into height. So if I run this program, it should say like the area of rectangle is okay. So it's having timeout issues. Let me just run it on playground itself then. Till then I will check if stream is fine. Yeah, I think stream is working fine. Yeah, as you can see, it said the area of rectangle is this much, 1500 square pixels. But no, it doesn't. We need a function to calculate area of rectangle. So instead of passing like two arguments, it will make much more sense if you just say here is a rectangle. So we need to group these two values together. So we can say as a rectangle. And if you remember what we used to group values together, then it will be tuple. So we can just say let rectangle 1 be 30 comma 50, and we are passing just one argument which will be our dimensions, and we are just multiplying the first with second. But you can tell right away that this doesn't look much for readability, because we can't really tell what is height and weight. I mean, if I made it, I can probably assume that 0 will be weight, sorry, 0 will be height, and 1, no, weight will be 0 and height will be 1. But if someone other person take a look at my code or wants to contribute or change something, it will be a huge mess. Instead, we want to make them meaningful. So how we make it? We use the struct to name that values. We will define a structure called as a rectangle, and we will have width and height. And then we will create it instance with specifying width to be 30 and height to be 50. And when calling the function, we will just pass a reference to rectangle, because as we saw, we don't want ownership of rectangle. We just want to access its value. So the reference is just fine. So we take a reference and we say rectangle dot width into rectangle dot height and return that value. So if I run this, you can see it's saying the area of rectangle is this square pixels. How struct can increase the readability and make your code much more organized. But can we do better? Yeah, we can actually do much better. But before doing that, let's see if we can print our structure, right? It will be useful to see if we can print it. So if I just, here, I declared a structure, I initialized it and just try to print it. Let's see what happens. It's taking some time. Yeah, see, it gives us error that the trait standard format display is not implemented for rectangle. What Rust does is it has a lot of there are a lot of formattings known by used by print line. Here the standard one which used by default is called display, and it is implemented by default for the common types, like the primitive types, integer and all that, because there is only one way to show the one. Like if you want to see number 12, there is only one way. But that's not with structs, right? You want it to be separated with commas, you just want the values, or you want the curly brackets or not. There are a lot of ways you can print the struct. Therefore, Rust doesn't make any assumption that what type you want, so it doesn't implement the display. But you can see here, note, in format string, you may be able to use this or this to print instead. So let's try using this. So close it and let me do question mark and run it again. Yeah, our code is still not compiled. Let's see what happens. The thread debug is not implemented for rectangle, and it is a note here that add this or manually implement the thread debug. So we can just add this instead of manually implementing. we can just add this line of code like derive debug above our struct definition, and now when we run it, it should print the struct. Yeah, it doesn't print like very nicely, so we can use this pound symbol or hashtag here to pretty print it. Now when we run it, it should print it in a nice format, and you can see it prints in a nice format. So what this debug format is doing, it allows like this debug thread enables us to print our struct in a way that is useful for developers. Like while we are debugging the code, there are a lot of things we can do with this, but we can do with derive, which we will see later if you want in appendix C. And our area function is very specific, right? Like it's for the calculating area of a rectangle. So it will be nice if we can just relate it with this struct, right? So that's what we are going to do next. We are going to use a method. Methods are similar to functions, like they are declared with fn keyword. They can have parameter, they return a value, and they contain some code that is run when they are called. But in the way they are different from functions in that they are defined within the context of a struct or enum or other things, and the first parameter is always going to be self. So here you can see this is a method, the function area here. So what happened here, we started with implementation block. So we are saying implement a rectangle, and inside that implementation block we are declaring our method, and as we saw, first parameter is always going to be self. And here, as our previous function just needed a reference, here we also need a reference to self. We don't need the ownership of self, we just need its reference, and we are going to return an 32-bit unsigned integer. We just calculate the area as we did earlier, self.width into self.height, and return it. Now we have this method, and for calling this method we use the syntax like dot area and then brackets parenthesis. So we can just call it like this, and if we run it to verify, it should just print this, and it's working perfectly fine. And if you want to change it, you can always pass a mutable reference. If you want to take ownership, you can pass self as it is, right? It's just like a function, depends on what we want to do. And if you are from C or C++, you might say, where is this operator, like the arrow which we use to, if you are pointer to a structure, we use this operator to access values from it. But here Rust does auto referencing and dereferencing for us, so we don't have to worry about it. We can just use dot syntax. Rust will handle it for us. And we can also have multiple, like here we started with self, but we can have multiple arguments also, but the first one will be self always. For example, this is a program where we just want to check if rectangle 1 can hold rectangle 2 within it. So width must be less and height also should be less. Same with here, we are checking if rectangle 1 can hold this rectangle 2. Same with rectangle 3, and this code prints this. So how we can declare the function? Well, as always, first argument is going to be self, no matter what, and the another argument is the another instance of rectangle, and we just want the reference for it. So we say it is of type reference to rectangle, and we are just returning true or false. And here we are doing checks like width should be greater and height should be greater. If both are greater, return true or return false, right? The result of this comparison This total comparison will be returns. So it will be either true or false. So that is how you can declare functions with multiple parameters. And then, sorry, this is not a function, this is a method. And then comes associated functions. Like these are functions and this doesn't take any self parameter. These are called associative functions because they are associated with struct. And they are a function, not method, because they don't have an instant of struct to work with. I mean, here, for example, this function, right? We want to create a square. So we just need to pass a size of its one side and the height and width will be same. So for that we can implement a function on the rectangle structure that doesn't take self. We don't need to have a structure already, right? In case of area function, area method, we need to have a struct already declared to have its width and height. But here we don't need it. We will just return the structure by setting both width and height of same size. And this is like one use of associated functions, and the way of calling them is using this double colon syntax. For example, if you want to create the structure of the square of side 3, you will use rectangle colon colon square 3, and we use this syntax for creating strings in all the previous chapters, right? The string colon colon from is an associated function of string. So it is the same thing. And if we say here, yeah, let me just copy it and to see it actually works. Here, if I just run it, it will not do anything because we are not actually doing anything. Let me print it. So I will say square is, and I will print it. Okay. So yeah, you can see it does what we want it to do. So if I say make it of size 14, it will do it. It takes a while. Yeah, width is 14, height is 14, and it is a structure of type rectangle. That is what we returned from here. So this is how the associative functions are used. And you can always have multiple implementation block, right? Instead of having just one block which contains all the methods, you can have multiple blocks, and these are perfectly valid syntax. Like you can have as many multiple blocks of implementation as you want, and we will see how they are useful in chapter 10. So this was all about struct. Like by using struct, you can keep associated pieces of data connected to each other and name each piece to make your code clear. Methods let you specify the behavior that instances of your struct have, and associated function let you namespace functionality that is particular to your struct without having an instance available. So these are just very handy features to know about, and they will be very useful in future no matter what program we are writing. And but structs aren't the only way you can create like custom types, and there are also enums, which is also called enumerators, and which we'll say in next stream. So for now, see you later.